Hey all, today we're going to talk about 3D figures, and we're going to talk about how to find the surface area of a 3D figure. And first of all, the surface area of a 3D figure is all the area on the outside of that 3D figure. So let's look at some examples. These are pulled straight from the formula sheet that you'll get at the end of the year on the SOL for the final exam. And we have a cylinder, a sphere, a cone, and a pyramid. And pretend you want to wrap these things with wrapping paper. The surface area is all the area that would be covered with wrapping paper. And the most important thing is to know where and what to plug into these formulas. So here in the cylinder we have a radius, and these circles on the top and the bottom, we call them bases. There's two bases in a cylinder, and the radius of that base is what goes into the formula for R. H is the distance between those two circles, or the height of the cylinder, and that goes in for H. And to find the surface area, all we have to do is plug those dimensions in and simplify. Very similar over here to the sphere. The only dimension we need is the radius, and the radius is going to come from a circle, a cross section right through the middle of the sphere. And we just plug in, and we can simplify 4 times pi times whatever that radius is squared. A cone has a couple new dimensions. It has a base, that's a circle, and a radius, which we need for the surface area formula. And then it has this L. This L is what we call slant height. It's from the tip of the cone down the side of the cone till we get to the base. Slant height is different than the height, which starts at the tip of the cone, goes straight down through the cone, and is perpendicular to the base, making this right angle. So to find the surface area of a cone, we need the radius, and we need the slant height. And just as a reminder, you get these formulas, so you just need to understand what the letters are and how to find them from a problem. In a pyramid, we have a regular height that goes from the top straight down through perpendicular to the bottom. And we also have a slant height. So for the surface area formula of a pyramid, we need L, the slant height. Little p is the perimeter of this base. And in this picture, the base is a square. So to find the perimeter, we just add all the lengths of the sides. So these 4 sides of the square, we would just add them up, and that is P. Capital B is the area of this square. The area of a square or a rectangle is just the length times the width. So we would multiply this dimension times this dimension, and we could get capital B. Another type of 3D figure we're going to look at are prisms. And there are 2 types specifically that we'll look at. The first one is a triangular prism right here, and a rectangular prism here. So they also have 2 bases. In a triangular prism, the 2 bases are triangles. Capital B, again, represents the area of that base. And H is the distance between the 2 bases. And again, little p is the perimeter of the base. So for a triangle, you just add up the 3 sides, and that will give you little p. We can use the same formula for a rectangular prism. The base is a rectangle, so the height is the distance between those 2. The area of a rectangle is the length times the width. And the perimeter is just adding up all the sides, just like we did for the pyramid. The special thing about the triangular prism is that we need to know the area for a triangle, and that's down here. This is also on your formula sheet. In a triangle, we have a base and a height as well, different from the actual prism. And to get the area of a triangle, we do 1/2 base times height. And you're going to see some triangular prisms that have right triangles as their bases. So in a right triangle, the 2 legs, the 2 sides that are not the hypotenuse, are the base and the height. So if you were to just look at the right side of this picture, so I'm going to get rid of this side, and I just had a right triangle, you can see that B becomes the length of one leg and H becomes the length of another leg. So to find the area of that triangle, we would do 1/2 times B times H. So I've got a couple examples for you, a couple maybe of the more important ones for me to show. Finding the area of a pyramid and finding the area of a triangular prism. And of course we'll do plenty of practice in class. So first, to find this, we need the formula. You should start by writing the formula every time. So we need the slant height. That's given to us right here along the outside, 26. P is the perimeter of the base, which is the square. So all four of these sides are 20. So I'll add 20 plus 20 plus 20 plus 20. And then B is the area of the base, which is just 20 times 20. So I've shown that here. And now we can just simplify until we finally get that the surface area is 1,440. Now if these had dimensions like 20 inches, 26 inches, this surface area would be 1,440 inches squared. Area is always squared on the dimension. Here we have a triangular pyramid, and you can see that this triangle is a right triangle, and we're going to need to know the hypotenuse, so we're going to use the Pythagorean theorem quick and find that. So Pythagorean theorem, 8 and 6 are my legs, so I put those in for A and B, and I simplify. I take the square root of 100 and the square root of c squared, and I find out that the side that I'm looking for right there is 10. So now I can find the height, which is the distance between these two triangles. That's 4. I can find the perimeter of this triangular base. It's 8 plus 6 plus 10. And then I need the area of the triangle. Remember from the last slide, the area is 1/2. And when it's a right triangle, we're just going to do 1/2 times the legs. So 1/2 times 8 times 6. You can see that right here. And now I just need to simplify. So the area of the base is 24. The perimeter, just by chance, is also 24. And when we simplify, we get 144, and I will call that kilometers squared. Since its area, the final answer's dimensions are squared. So I'm cutting you some slack today. There's no you-dos. We only did a couple examples. We'll do plenty of examples in class using the formulas, finding the dimensions we need for all the different types of 3D figures.